Hi there and welcome to this very special live stream edition of the Elektor Engineering Lab Talk Insights Mash-up. Yes, it's me, Stuart Gording, the electronics reporter here at the Elektor stand at Embedded World even 2023, and I'm joined here by my colleague Jens Nickel from our Lab Talk show. Hi Jens.
Hi Stuart.
How's the first day of Embedded World gone for you?
It's again very interesting. There are really crowded halls. I was again amazed. For the first day, there are really a lot of people, and we have 6 halls packed with interesting things: IoT, artificial intelligence, and stuff as Matter and new protocols and so on. So there is going a lot in the scene, and I'm not sure, but I think they will break the visitors record, the all-time visitors record, and that's very good to see after the pandemic, after this whole. And it's good that we can meet each other in person again.
That's right. So looking back at the last couple of years, COVID has obviously been a very challenging time, causing the Embedded World Trade Fair to actually have to be cancelled on a couple of occasions. Last year we were back and had the opportunity to meet again for the first time, but the visitor numbers were still down a bit. But that's probably partially down to the fact that the show took place in June instead of the March-April timeframe, which is more usual for Embedded World. And of course that makes it very difficult because people have got lots of other activities already planned and trade shows that they're attending. But I have to agree with Jens. I've been walking around the trade show floor today as well, and we're seeing a lot of all the same types of technology. Everybody's trying to make up for lost time and show all of the stuff that they've been working on in the background. So I've also got a list of things too as well, which are more or less aligned with what you've seen. We've been talking RISC-V, Matter as an IoT solution, Tiny ML for machine learning and AI, and some other bits and pieces as well. So, but before we continue, what I'd like to do is invite our colleague and editor for Elektor onto the show, CJ. You're going to come and join us. There we go. We've got a microphone for you as well.
Thank you.
Feel plugged in.
Yeah. Great.
So, CJ, you've also taken a walk around the show floor. What have you been looking at?
Yeah. So I just have my notebook here, so I'm going to kind of just go through some of the things that I saw today. Now, I went to a bunch of meetings today. Jens was in a couple. So I didn't have a chance to dive into all the technology, but what I did was I took some notes, and these are some of the things I want to return to tomorrow. AWS has a big booth. There's a robo tap room for beer, so they're using AWS.
I want to do a report on this.
Yeah, it looks really cool. So they're using AWS for that.
Yeah. So also, just stop there for a second. So with that AWS demo, I mean, what's it look like for people who are stopping by, and how's it seem to work?
It looks like 4 or 5 beer taps with a couple of screens, and there's all of this data being pulled about. I don't even know, so I have to go and check it out.
Yeah,
but they're monitoring that.
There's a monitor how the data is flowing in the cloud and to every station and then back. To me, it seems a little bit complicated for a beer tapping robot, but this may be the future. And I think what we saw here is that these complicated things in the background has to be covered by some sort of comfortable front end for the end users, because it seems to be so complicated, all that stuff, and there's also security and certificates which must handle it and so on. Yeah. So I've seen a lot of interesting solutions where these complex things are simplified, so the users can comfortably deal with.
But I think this is a nice sort of demo for Germany, isn't it? We have the engineering excellence coupled with beer. I mean, it doesn't really get any better than that, does it?
Yeah. Also, at that same booth, AWS, there's a smart home application with ESP Rainmaker using Matter.
Right.
So that's expressive.
Yes.
So I'll check that out tomorrow as well. So there's a bunch of different applications there that I want to see. I went to Raspberry Pi. I don't know if you guys had a chance to go there
Not
today.
at all, no.
I went over there. Obviously, their cameras are on display. I saw a bunch of students looking at a demo of the global shutter camera. You can go onto the Elektor website to check that out as well.
Because that's something that we've covered recently in the magazine, isn't it? Because that was recently launched.
Yeah.
So
the global shutter camera. Yeah. So we have a news item about that on the website now.
And that Rainmaker thing, I think we should also cover.
I think so too.
Yeah.
For sure. RISC-V. So we went over to RISC-V earlier today. They're right down the hall here. Pretty cool. They have a bunch of demos from partners. Andes and Imperas are two of the ones that I want to check out tomorrow.
Yeah.
So that's pretty interesting.
I think the guys from Imperos we've had on the Engineering Insights show in the past as well, because that was one of the things that I also saw today. Espressive, with lots of people are talking about RISC-V, but it's not really clear sort of how many microcontrollers are actually out there to try and use it. But Espressive is one of those suppliers that's actually using quite a few RISC-V cores, or that they have them available in a series of SoCs. And we were just talking to them recently to find out about half an hour ago what's new, and they're actually, not only do they have RISC-V based SoCs available, they're actually going to be bringing out a dual core RISC-V device, and that's probably one of the first ones that's more publicly available for experimentation and getting to grips with RISC-V. So
cool. What else did I have? Phytech has a cool demo. Penplotter, they're drawing the Seattle Space Needle. They're based in Seattle.
Right.
So that's a pretty cool application. There's a bunch of industrial automation applications going on here today. So that's one of the big topics of the show, for sure. Looking big picture, in addition to industrial automation, machine learning and AI, which you guys already mentioned, is big. Even at the ST Micro booth right down the way here, they have 3 or 4 AI applications. And the third thing I wrote down here is embedded security. So of course that's super important.
Yeah.
It's been important here in the past. It's only going to get more important moving forward. So those are the 3: machine learning, embedded security, machine learning AI, and industrial control automation.
Now, security is one of the big issues. Obviously, everyone's very keen to get their Internet of Things applications up and running. We're also seeing networked vehicles. I've been talking to ARM today about the state of software-defined vehicles and how they're developing. But one of the real challenges is making sure that the communication between all the ECUs and also the nodes for IoT, that data communication is secure. Now, one of the big players in this space is NXP. Obviously, other companies like Microchip and also Infineon have various security solutions as well. But the challenges obviously is in implementing security. The challenge is then actually making it work, because you need security certificates. You need to do a process called provisioning, and I think this is one of the things that we see on the AWS platform. And also talking to Espressive today, what they were saying is they have a complete IoT module, which is something that's actually defined by AWS to make sure that using secure IoT is much simpler to implement, because obviously if it's difficult, people are going to look at ways around it or avoid doing it altogether, and we don't want that, do we? So,
an interesting question that could be something of a topic for one of your shows would be, where is security implemented? Is it implemented on the edge, or is it implemented with the master device, or both, or how?
Yeah,
so you need both.
Yeah.
And I think
that's a difficult
hardware
challenge.
Against attacks.
One of the other big issues that we're facing at the moment is obviously the growth in quantum computing as well. When we were at Electronica, we were chatting to some of the people who were sort of making quantum computing possible. But the risk is that quantum computing is actually going to make today's security obsolete. So it's going to break it. Now, I know that, again, NXP is one of those companies that's working on quantum secure security, and it'd be interesting to find out from them how far along we are with that and when we're going to start seeing solutions. So I know that some new algorithms have been approved by the NIST, that's right, in the US. Yeah. So be interesting to see how far along we are with those, and when we're going to see some silicon to support it.
Yeah, I mean, it seems that a lot of the main players in the industry now even have cryptographers on staff now. It is definitely part of what they have to build into their solutions. So.
Yeah, no, exactly. So what else caught your eye at the show today in the RISC-V space? Have you seen any RISC-V type applications?
I have to admit, no.
Not yet.
But I've seen a lot of interesting solutions about machine learning.
Okay.
In the field of machine learning, and yeah, at a lot of booths you see small things with different sensors on it. So AI is dealing with sensor fusion, and you have a reduced amount of data going out. And there are really interesting small modules. At Nordic there is a small module literally called Thingy. So that's also equipped with a lot of sensors, and yeah, I think that for our readership and the Elektor members will definitely be interested in that, because that can be the first step into that machine learning field.
There was another gentleman I spoke to today, a guy called Blair from Newton AI, and he was sort of taking me through their platform as well. So it's another tiny ML, tiny machine learning platform. It's available for free as well, so you can develop all your machine learning, and you can go right from the very beginning through to the model development and deployment then. And sort of their specialization is on really getting a very highly efficient model that you can deploy to a microcontroller, but it's also a solution that's microcontroller agnostic as well.
So I don't know their solution. Do you kind of sandbox something and you test it with their software, or are you actually implementing like a tiny ML application that's in use in the real world, or is it for testing purposes?
No, it's really to actually develop models that you can program into a microcontroller, so they have a nice small footprint AI code that results out the platform. But one of the challenges in this process that we were talking about as we were exploring sort of how best to deploy it and where to see in the most traction is that there's obviously lots of applications available on the market, lots of demonstrations which are around sound and voice. You know, these voice AI and wake words, for example, are a key example. So there's lots of demos for that. And it proves the point that machine learning is a tool that can be deployed on a microcontroller, but then you go to sort of like an industrial customer, and they might want to do, say, preventative maintenance, but nobody's ever done that for a rotating motor or for a pipe to look for water leaks or gas leaks or anything like that. And that's sort of where it stumbles. It's sort of like, well, we can't see a demo of that working, so therefore we're not really quite sure if it's ready to support our application. So what they offer alongside the platform, which is free, they offer sort of services to help people tune their code, analyze their data, and help them train the model so that they can actually have success and do it. And what we're seeing is, like, as they do that, seeing more traction in the industrial space and other places beyond just sort of consumer type applications.
Do you think there's sort of a lot of I won't say crap, but junk applications out there? I mean, it's a buzz, it's, machine learning, AI. I mean, I'm sure there's a lot that's just going to disappear. Do you see that, or do you think there's, a lot of the stuff that we're seeing has some legs?
I think that's what Blair highlighted is the big problem. We've got things which are sort of slam dunk type applications, but they, how are they really applicable and how are they helpful? In the consumer space, we can make loads of little gadgets and all sorts of things, but why are we doing it? And how is it really helping? And my feeling has always been that AI in the embedded space is really going to help us with the with those industrial applications, so sort of preventative maintenance. How can we be sure that the motor bearings aren't damaged? How can we be sure that sort of the structural integrity of a building or a bridge is there? We can't just rely on continuously sucking data and transferring it to a cloud-based environment where we then analyze the data. Some of that needs to be done locally.
I also think so. I think AI will help us to reduce the waste of data, which are really not needed. So and I think that's good.
That's the opportunity.
For example, I was at Infineon and they showed me an application about position sensor for larger motors, and it's also powered by AI. And I asked, why do we need AI? It's we have position sensors. And he said, yeah, okay, position sensors of that precision we need are costing several thousand euros from time to time. So they found a solution that the AI is monitoring the current and the voltage and can be calibrated with that expensive position sensor to replace it at the end. So you have at the end a €5 module which does the same with the same precision. So that's, for example, an AI application we even thought about, and I think there will be more in the future.
Solutions you're talking about, as opposed to like when you go into some of these development platforms, you just see people have tons of ideas and they're adding or attempting to add AI to everything, and you sometimes just wonder like how much of this is going to stick.
Yeah.
That's really cool. And which company was that?
That was Infineon.
Now, there's another area where I've also seen some traction in AI is not necessarily in the units itself, but using AI in industrial applications to actually improve the testing phase of things like gas meters, for example. So gas flow meters for industrial applications, they need to handle many different types of gases, and they have to be calibrated. And that calibration process is exceptionally complicated. There's so many different parameters, and this is again an area where AI can sort of look at very disparate data, but find the pathways through it which are the valid ones, the ones that are going to work. And so AI is also being used in that process to actually do calibration, which otherwise would just take weeks and weeks and weeks, and it takes it down to a process that maybe only takes a few hours. So AI doesn't necessarily need to be deployed in the electronics and in the systems that we're talking about. It can actually be used to help us build better systems, much in the same way as you're saying. We're sort of making a sensor more accurate just by using a more accurate sensor as a reference as you're designing the sensor. So that's really cool. So that's a lot of the background data there. I'm just trying to look at some of the other things we've been talking to. We were talking today, or at least I was talking today, to Eurocircuits. It's one of the big European-based PCB manufacturers who are exhibiting here at Embedded World 2023. And obviously, one of the big challenges with PCB design is then releasing it to have it manufactured. One of the things that typically happens is that everything's absolutely fine except for one footprint, or a couple of tracks are too close together for manufacturing processes. And over the years, I think talking to Dirk Stans there, I want to say one of the challenges we've had over the years, maybe in Europe, is we've focused too much on specialization and thought, well, PCB manufacturers need to focus on PCBs, and then assembly specialists need to focus on assembly. And the challenge there is, you can get really deep and very niche in your space, but then of course, as a customer, you need to go to 2, 3, 4, 5 different people in order to put all of that stuff together.
Which isn't super convenient all the time.
No, exactly, So what they've focused on is sort of trying to bring more services together, but also remain deep, get that specialism there, get the quality control methods in place, but almost start to become again a bit more of a one-stop shop where I can go with my PCB, I can get it assembled, I've got housing available, things like that.
Yeah, and you're European-based, correct? And
it's European-based as well, so I think this is also one of those challenges as well, as we're looking at global unrest and things changing. Can we get stuff done locally instead of going to Asia in order to get those boards manufactured? Yeah,
and I know for many of the European engineers, eco-friendly design is an important thing, and I know that that's something that Eurocircuits focuses on quite a bit as well. So one of the interesting tools that they have is their PCB visualizer. So you can actually take your Gerber files and upload them, and obviously the first step, and something that almost every PCB manufacturer offers, is the ability to visualize that as a 3D model, which is still very nice, but obviously you want to get further on than that. So their tool actually does then analysis of the track dimensions, make sure your gaps are correct. This is one of the surprising things is the number of boards that come in, and you've got a list of parts,
and you've then got the board design, and when they put the two things together, all of a sudden they realise that there's one part where the footprint's wrong.
Yeah.
You know, so, and that's something you want to catch early before you then start manufacturing boards.
So how long until they're using AI for?
Well, this is the question, isn't it? Yeah, I mean, it's another one of those classic situations where if you've got access to all of that data, you're seeing lots of designs come in. Can AI play a role in that in order to optimize that process and help out?
It's interesting. I think a lot of companies are going to start, if they're not already, asking that question. How can we use AI in ways that we didn't even think of? And we've already started talking about it a little bit too, even in terms of content, right?
Yeah.
We don't have to go down that road, but.
So who of us have been writing our articles using ChatGPT?
Yes, no, you did that. We've had some videos on that too. Yeah, it's interesting. But we'll have to see what happens with it.
What's been your experience with it thus far?
Truthfully, just playing around with it.
Yeah.
Not much more than that. I mean, we haven't used it for anything that we put out. So yeah, just testing it and seeing and listening to what users are saying and colleagues, and that's pretty much it for me.
Yeah.
You've written about it.
Yeah.
Jens has tested it out. I forgot what you tested it for. You said
I asked ChatGPT some questions about solar systems and necessary batteries, and the answer was, from my perspective, right. Yeah. And he even, or it could even limit or think about limitations of the expressions of the answer.
Yeah.
So I think it's interesting.
We have a really good video on the Elektor TV channel right now where Clemens Valens, one of our senior engineers, plays with it, and he asks some technical questions from the point of view of an embedded systems engineer. So I won't go into it, but you should check it out. Go to the Elektor TV channel. Yeah. And take a look. It's pretty interesting.
In the most recent edition of the magazine, which we've got here at the show, I was looking at embedded and how AI is being integrated more and more into different types of microcontrollers and embedded applications.
I think you can show one copy.
Exactly. Let me just have a quick. There we go. Oh, this is the German version. There we go.
So if you put it on the table, I can.
Exactly. So we got that one there.
Show a little bit.
It's got the English one here. Oh, there we go. Look at that. So there you go.
Yep.
So that was interesting. And one of the things I did with that, there's lots of different AI tools, as you know. It's not just ChatGPT. One of the things we looked at in there as well was the DALL-E 2, which is this visual tool.
Yep.
One of the amazing things about that is that you can give the tool an image, for example, and ask it to extract something from the image.
Right.
So there's an example on the website where there's a picture of a room. There's a small little swimming pool in the room and a little blow-up flamingo, I think, sitting on the pool. And you can say, can you just remove the flamingo? And that's all you have to say.
Yeah.
You don't have to do anything like you would do with a graphics tool. And it just removes it out of the foreground and replaces it. There was also I think it was Vermeer's Girl with a Pearl Earring, for example. And they took that image and said, can you paint the rest of the room? What does the rest of this environment look like? And it came up with a very realistic feeling room where this girl would have maybe sitting in a parlor or a kitchen or something like that. We did ask ChatGPT to write the last paragraph of my article, and I thought it came out really well. You liked it, didn't you? Because you wrote to me about it and said that was good. But I've also done some other things as well to try and get into it a bit more and see how accurate it is. I asked it some very niche questions around SiC MOSFETs, for example. I was quite impressed by the answers that came back. But I think if you try to ask it to write something, I gave it sort of 10 points. I said, like, these are 10 things or 5 things around a specific topic. Can you inform me about them? And the answers then come back as very formulaic. It's like, well, to point number 1, I found this and this and this. So I think the idea really is it's supposed to be a conversational tool. And it's probably something where you then need to keep going back and asking questions to actually get it to flesh out a bit more.
You have to refine your questions as well, I think.
Yeah, exactly. So, but it's it's incredible what it's quite capable of, and especially for us, I do a lot of writing, obviously for the magazine, but also for other people as well. And sometimes when you're looking for some inspiration or a different angle, sometimes it can be helpful and give you a sort of a jolt.
Yeah, I think for sure if you have writer's block, if you just ask a question, sometimes it could just help you sort of frame.
Yeah, exactly. So yeah, we shall see. We're not out of work yet.
No.
But maybe next year we won't be. We shall see what happens. One of the other interesting parts of what's going on in the embedded world community at the minute as well is maybe the first signs that C, C++ is not going to be the language you use to program microcontrollers anymore. Now, one of the first topics we have is MicroPython. We just did that interview with Sebastian Romero from Arduino.
It was really successful.
That was interesting. Did you get a chance to see some
I watched the whole webinar.
Oh, wow.
It was really great. Yes.
Even when my camera turned off. You saw Freddy the face as I tried to get it all back in focus again. But
that was great.
That's an interesting point. And when we did that, the magazine together with Arduino, which came out at the end of 2022. Now, one of the interesting things that came out, and I'm not sure if it made it into the article, but when I was interviewing Sebastian, what he was saying to me was that Python is really sort of the language of machine learning, of AI for PC and cloud-based developers. And those companies that are looking to integrate then some sort of machine learning or AI into a microcontroller, what they're saying is we don't want to start them programming in a different language. Now, obviously, we can't just take the code we've written for the cloud and then compile it for a microcontroller. We can't just make that simple move. However, their team still wants to be able to program, so MicroPython gives them that opportunity. And then the other key language change which we're possibly going to see, which I think is probably more realistic for replacing real-time applications, because MicroPython's probably not the best for real-time, is Rust. Rust is coming up all over the place. One of the startups over in Hall 3A over there I was talking to is a company with a real-time operating system written in Rust targeting automotive applications. So I think that's probably one of the most challenging environments to be in. I've got a new programming language, I've got a real-time operating system, and I want to encourage the automotive industry to use it. But we were talking to them. The operating system is called Oxid OS, and they are making traction in that space. They've got some of the microcontroller vendors on board to do some demos. They're also talking to various OEMs and tier ones, exploring what they want to do with that. But and the big interesting part about Rust OS is probably the safety aspect of the language. It's very safe. I mean,
why is that?
The problem with C and C is it's very easy on embedded systems as well to sort of consume memory, do buffer overruns and just write to any piece of memory you fancy. There's not really any limits. And what they were saying is, especially in the automotive space, there's lots of processes in place, there's lots of tools in place which help you to make sure you don't make these programming mistakes, which can cause failures, and obviously functionally safe systems. We don't want the braking system, which is software based, to fail, or the steering system. So Rust just basically doesn't let you do any of those things. If you need to do anything that's, let's say, dangerous in terms of memory accesses, there are ways of doing it, but you have to explicitly say, I want sort of like the safety net removed for a minute so that I can go ahead and do that. So
and because I'm not super familiar with it, is that purposeful, or is it just because of how Rust is created?
Yeah, so Rust is sort of safe from the ground up. It's really designed to be a safe programming language where these sort of classic C mistakes that can occur. I mean, the point is, you can really have a pointer to somewhere in memory and forget where it is, and it can then sort of explore, and before you know it, you're writing things that you don't want to write. You're changing the values in registers where you really want to be changing them in SRAM. So it's a mistake, it happens. So Rust really looks like it could be a sort of secure method.
Is it difficult to go from C to Rust if you're
I think there is some learning curve.
Yeah.
Until you get familiar with this ownership things.
Yeah, exactly.
It's not so easy, even I think for programmers who are used to programming C.
Yeah.
But I think it can be learned.
Yeah.
Okay.
I think, I mean, there's a learning curve. It's not quite a one-to-one move, and one of the other aspects of Rust, of the Rust language, is that it moves more into the realm of having libraries and packages. They call them crates. Yeah. So you create a crate, that's where your code and your application goes, and then you sort of pull on other crates. In some ways, it's similar to the Arduino environment. So the nice thing about Arduino is that if I want to use the I2C interface, I don't have to learn all the registers, how to configure them, their relationship to the clock. I just open a library, just pull it in, and then I can use I2C. And Rust is sort of going down that same route. So you have these crates which have standard interfaces. So there's a crate maybe for the processor, there's a crate for the peripherals.
How do you know which crates are available to you?
Well, this is part and parcel of the learning process, I think. Yeah. So if you study it and you look at it in some more detail, especially for embedded systems, these crates are being created, and there's some structure and guidance. Some really good documentation on the internet about this.
Cool.
But I think Rust was originally designed again as a web browser programming language to sort of speed up and develop on the cloud. But people feel that the safety aspect of it, that you can create really robust code, that's also something deserved of the embedded systems environment.
Interesting.
One of the interesting things, though, is to understand who's actually going to be able to support Rust, because as far as I know, you need what they call an LLVM compiler, and that's not available for all different types of processors on the market.
Right.
So LLVM is a sort of a compiler tool chain which allows you to attach various different compilers to this tool chain that then chucks out the binary code at the rear end. And you can put a Fortran front end on it, or a C, C++, Rust, Python, whatever it might be. But not all microcontroller vendors have an LLVM compiler tool chain available. So if you don't have that, as far as I can understand at the minute, your microcontroller's not going to support Rust. Yeah. So, that doesn't touch that many vendors. Things like ARM, for example. Oh, we've lost something over in the background there. So lost some trees, very noisily, in fact. So we've got companies. If you've got an ARM-based core, then you've got an ARM compiler, and there's an LLVM tool chain available for that. So, so that's going to be an interesting area. I'm actually working on a Rust article that's going to go onto the web very soon.
Yeah.
So I'll share my insights that I've garnered over the last few months.
Do you have experience with Rust at all, or just?
I just read some courses superficially in some magazines.
One of the easiest ways to get started, to get a feeling for it, is actually on Raspberry Pi. Because obviously you've got the Linux environment there, you can just write a few programs in Rust. And there's some good tutorials online as well, which allow you to experience also controlling peripherals. So you can connect an LED, blink it, respond to a button press, and just get a feeling for that. So that's another interesting area of what's going on. The other one, I think, the other big one, as we're seeing, the big theme is Matter.
Yes.
So what have you found out about Matter so far? Does it matter?
It does.
It definitely matters. There's literally no semiconductor company who hasn't a Matter booth or a Matter demo. So all the companies are very interested in not to pass the train or miss the train.
Yes. Yeah.
On the consumer side, there are not so many devices yet, so the process is starting.
But that will catch up, I'm sure.
Everybody wants to be a part of it.
Yeah.
So I think there is a need for such a system, because that was, I think, one of the biggest problems of home automation or automation in general, that the things are not compatible to each other, and now Matter could overcome this. Yeah. So I think there's definitely a need for it, and
But it's an interesting question would be, we've been hearing about the Internet of Things for 10 years, and so it exists. So presumably things are connected to the internet, and they're interacting. And we've all heard of home automation. We actually have it in our houses and offices and apartments. So what is it that Matter is solving that you thought was in play for the past 10 years?
Yeah. I think the key thing, as I understand it, is that we obviously have a disparate range of IoT protocols.
Yes.
We've got things like Thread, Zigbee, you've got Bluetooth-enabled stuff, you've got Wi-Fi-enabled
yep.
stuff. Wi-Fi is obviously moving forward as well into the IoT space. Now, if you've got a big battery-powered application, say a home speaker or something, then you don't really care too much about the power consumption of Wi-Fi. But if you've got a very low-power sensor that's got to last for a year or more on a battery, up until now, Wi-Fi hasn't really been a choice because it's too power hungry. So Wi-Fi 6 is now entering the market.
Yeah.
We're seeing that is the entry point for lower power Wi-Fi IoT nodes. But the problem is, of course, if you've settled for Zigbee for your platform, you don't have Zigbee at home, so you need that gateway, and then your Zigbee switches and light bulbs may not be compatible with the Zigbee switches and light bulbs from somebody else, or the back-end cloud services that are associated with it. And they're definitely not going to work with a Wi-Fi light bulb or a Bluetooth light bulb. And that's really sort of the sticking point. And while everybody's obviously invested a lot of time and energy and trying to hedge their bets by supporting everything or maybe supporting only specific things, the losers at the end of the day are the consumers, because they end up with a load of stuff that's not interoperable.
So in many ways, a lot of things aren't connected.
Yes, exactly. Well, they're connected, but they're not connected with each other.
They're not connected with each other.
We've got islands of IoT.
Yes. Interesting.
One of the interesting things in Hall 3A again was talking to the guys from Espressive, because they're also supporting Matter, but they've got a really nice demo there where they have Wi-Fi, they have Thread, I think there's Bluetooth as well, and all of these different wireless protocols and wired protocols are all linked together with this sort of Matter layer over the top. And you've got a Thread-based light switch and you've got a Bluetooth-based light bulb. They are able to communicate with each other even though they're not on the same system. So I think Matter is going to be another big theme. Definitely, we're seeing it here. We're going to continue to see it. And in some ways, I was reading something that Daniel Cooley wrote from Silicon Labs. We're going to be talking to him tomorrow. But I don't want to, hopefully not misquoting him, but he was saying something along the lines, it's a bit like a bit of an IoT reset Matter, in order to sort of get it to where we dreamt it of being when it sort of started and kicked off. And in terms of IoT, we're really only at the beginning, of the process. There's a long way for this to go, and we're still figuring out how best to make use of it.
Stuart,
yes.
A guest of mine has arrived.
Excellent. Please come and take a seat.
Thank you. Here, actually, I'll hand off this.
Yes, exactly.
You need this.
So thanks very much, CJ.
Thanks, guys.
Good to have you here. Just going to take the microphone. So there we go. Welcome to our Mash-up show. It's good of you to drop by.
I'm very curious. Yes.
This is what we do at embedded trade fairs, or all trade fairs. We do it at Electronica. We're doing it here at Embedded today. So tell us a little bit about yourself for people who've not met you before or not seen you elsewhere.
Yeah. Okay. So
you have to, Vyacheslav, you have to go a bit closer.
I have a longer history with Elektor and Jens.
I remember it well when I met you the first time. It was on an Elektor Live event. And you asked me some things about source code, and you wanted additional source code for one project, and you were very, very young at that time.
I think 13 or 14 years old, and then Jens gave me the possibility to publish some stuff. Then we made also the ARM Cortex-M course and such huge articles in Elektor. Then I have a really non-usual background with high ability studies in embedded systems and so on, and then I founded 2017 ITAT, where we around about 20 persons now, growing to 30 in the Offenburg, so between Freiburg and Karlsruhe. and working on embedded AI. Like the really local AI on chips. I see it like is the last step after the whole history. Like the first AI was on big servers, on big PCs. Then the edge AI came like 2010 years. And now embedded AI, like fully autonomous AI, non-dependable on networks, the whole pre-processing, processing and scoring in one chip or on one board. Either it's in machines, either it's in cars or in house appliance. And the cause why I'm so hyped now is I'm coming from the Embedded Award and we won it in
Congratulations.
AI.
Hey,
Well done.
Thank you very much.
Fantastic.
congrats.
So we were nominated like Amazon, ITAT and AMD, so
Right.
two huge ones.
Yeah.
And we did it.
Excellent. Congratulations. Well done.
Thank you very much. Thank you.
So are you exhibiting here at Embedded World as well? Do you have a stand or?
Yeah, we have basically like a daughter stand at the booth of Silicon Labs where we're showing this use case of shower monitoring, this product with which we won the award.
Okay.
And yeah, quite happy here.
Then tell us a little bit more about that application. How's it implemented? What's it doing?
Okay. So, like the special one or just
The one you won the award for.
Okay. Yeah, so it is a shower monitoring through infrared sensors, 8 by 8 pixel or 32 by 32, so it's scalable.
Yeah.
And it's fully local running AI on it to do several use cases. For example, for public showers, you need to determine where are the person under the showers. And you have also, like the European Union has a certification course where you need like every 4 hours make it hygiene, so nobody should stand under it and it runs hot.
Okay.
So then the second use case is for disability. So the AI sees if someone is in wheelchair in the shower, and if some assistant is still in the shower, it just don't go on.
Yeah.
And the third use case is the individual shower. It was a German company for whom we did it. And it's about like the AI looks at you, like fully private sphere, because it's infrared, it's just pixels.
Okay.
You can't do something with this. And fully local, it's processed for like recognizing how hot are you. Like for example, if you went for a jog and you're overcooled, then the shower detects it and makes the temperature curve like adequate and adaptable to that. It's a kind of comfort function. All in one chip in the MG24 from Silicon Labs, which is quite new and costs like a few dollars. So, and this is the whole AI solution, like the small board.
And so, what's your development process for AI? Are you using other people's development AI platforms, or do you have your own that you're using to do these things?
I think that's what makes us very special, because we have the whole process pipeline, like from consulting of possible solution to the certification in-house.
Right.
So we are now on 3 levels in Offenburg. We have a production, so we can make small series, like pretty fast, 2 to 4 hours, few hundreds or thousands boards. Then we have the servers also on site where we train the AI, and we have all this full stack engineering. So we have electrical software engineers, hardware engineers, data scientists and mechanical engineers just for housings, lenses of optical sensors and so on.
And you know, for people who are entering, we're saying today at the Embedded World, we've seen a lot of tiny ML, we've seen embedded AI continuously to grow as a topic. In your experience, what's the most challenging part of the algorithm development process, or the construction of AI in microcontrollers?
After the huge like problem or like just thing you need to face is the data collection and data labeling. So it's this the reason why we take, for example, cars in our test benches just to run them and collect data day and night.
Yeah.
Why we get house appliance also in our laboratory to run them day and night. We have kitchen stuff where we're cooking like 30 kilograms of burgers a day just to train the AI.
Okay.
And you never can get enough data.
Okay.
So you need always to augment it.
Yeah.
So, and augmentation is like not this kind of augmentation like 5 years ago now. It's more augmentation through AI. So if you imagine like a picture, like in the past you make like better grayscale or more contrast or flipping something around, make some failures in the pixels and so on. And now we use like the kind of technology of deep fakes, like the GANs. They are looking at the real acquired data, for example, of pictures of cooking stuff, for example, and then they generate like deep fakes, like the virtual but real shaped data. And this is the reason why we can like multiply our data pool by times 100,000 or more.
Yeah.
This is the first process pipeline, which is difficult. The next process pipeline, which is also like the most know-how thirsty, is to get the huge AI trained on servers, well trained, well performing, but huge to a small chip.
Yeah.
Without losing a lot of capabilities and so on. To do it real time, it can't like an inference can't take seconds. It should make like 1 millisecond.
Exactly. Yeah. Now, I was going to say one of the interesting aspects of the semiconductor industry is they're all trying to make machine or AI execution on the chip much faster, much simpler. And you're typically seeing some sort of AI accelerations or dedicated instructions to make that work better. In your experience, sort of using these things, is that really necessary, or do you think standard microcontrollers you can just run the code? The accelerators are not particularly helpful in those cases.
Depends on the use case. For example, for predictive maintenance, it's often it's not real time.
Yeah.
So you can like just decide in hours, days, or months.
I see.
So you can run the inference over days, hours. So you can run it probably also on an 8-bit microcontroller.
Yeah.
Like it's working the whole time. It doesn't need to be accelerated. But if you have some real-time stuff, for example, safety detection of failures or detection of speech or something like that, it needs to be like real time, and then the source of the data and the shape of the data decides what kind of elements can be helpful for that.
Yeah.
It could be an accelerator and an MCU like Ethos U55 or the Cortex M55, but it could be also something totally different. For example, you need some digital filters to make the pre-processing better, because it takes more time than the model itself.
Yeah.
Or you need a graphic accelerator just to decode pictures or something like that. So AI acceleration is not just the NLP processing unit, the NPU, I'm sorry for that. It can be some different kinds of elements. Also like a 2D or a 1D DMA to stream data.
We're coming to the end of the show. I think we're starting to run out of time. Have you got any final points and questions?
Yes, I have a final point. I want to welcome all readers, all people who are in Nuremberg, who wants to go to Nuremberg, to the Elektor booth. And we also have some goodies. For example, for all people showing up, they can have a 4 months free subscription for MicroPython, and there are also goodies in there.
Nice.
There's a Pico board, Pico, and
nice.
And
there we go.
Yep. Of course, a MicroPython and stuff.
Super.
So if you are here, if you are in the neighborhood, step by. At the Elektor booth. It's 4A in the corner, 646.
646.
Yeah.
So there we have it. We've run out of time today because we've all got to get to dinner after the show and go and do some more interviews, go and chat to some more people, and there's plenty of other things going on after Embedded World. Today I'm going to visit the IoT stars and find out more about what they've been up to. We talked to them last year. Go and find out how some of the startups and other IoT companies have developed in the past year. Maybe get some updates and information on Matter. And there's various other things going on as well. So thanks ever so much for joining us today. Thank you to our guests, CJ and yourself, Jaroslav, to come along and tell us about it. Congratulations again with the award. And please stay in touch. We've got Lab Talk from Jens. We've got Elektor Engineering Insights from myself, regularly on YouTube. My show's also on LinkedIn as well. So drop by and keep yourself up to date with everything involved around electronics, software development for embedded and semiconductors. And we'll see you again soon.